Welcome back. In the last lecture, we have studied about graphical representation of uniform motion. In this lecture, we'll study about graphical representation of uniform accelerated motion. So for uniform motion, we have learned about distance time graph and velocity time graph. Once again, uniform motion means your speed is constant or your speed is same. In this lecture, what we are going to study about is uniformly accelerated motion, velocity time graph of uniformly accelerated motion. And uniformly accelerated motion means your acceleration is constant but speed is not constant. Your speed or velocity is increasing or decreasing regularly or at regular intervals of time. So both uniformly accelerated motion and non-uniformly accelerated motion we are going to study. Let's start. This is your data that we are going to plot. So velocity time graph showing uniform accelerated motion. So this is the data. This is your graph. Same like we have done earlier. We will choose one point one by one and draw lines. So starting with first point 0 to 0, you will get point over here. Then 5 and 2.5. So draw perpendicular line. So the point where these two intersect is your point. Same like this, you have to put different point, and when you join them you will get a line like this. So in uniformly accelerated motion you will get straight line, same like uniform motion. Here also you will get straight line, but here graph is between velocity and time. So earlier what we have is here distance. Now what we have here is velocity, and here we have time, and this straight line is telling you about uniform acceleration. And now curve of any type. So this is curve, you can see it's not straight, it is keep on changing. So this is graph of non-uniformly accelerated motion. Now in earlier lecture I told you about how to find distance from velocity time graph. Here also we'll do same thing, but here motion is not uniform but it is uniformly accelerated. Let's start. So you have this what we have done earlier in velocity time graph. This showing of speed is constant, and by plotting these you can take any 2 points, and by simply finding area of this rectangle you can find distance. Okay, area of this rectangle, that means velocity into time, that will give you distance. But here now your velocity is not constant. Now this type of graph you have, so simply mark the points. So this is your points, choose any 2 points. Okay, so like this, see this point and this point you can choose, or these 2 points you can choose. This is up to you which point you want to choose. So just draw perpendicular lines. So here is your perpendicular line. But here if you see, this figure is not your rectangle. See, this is not rectangle, this is something different. So directly you cannot find out area of this figure. So what I will do is I will draw a line over here. Now if you see, you have two figures. One is this, which is triangle, and one is this, which is rectangle. So now I will just name this. This point is your A, this point is your B, this is your C, this is point is your D, and this point is your A. So now what you have to find is, to find distance, you have to find area of A, B, C, D, E, which is nothing but area of triangle plus area of rectangle. What is area of triangle? Half into base into height. So, and area of rectangle, length into breadth. So if I do this, so half into base. What is base of this triangle? AD, this line. So this is nothing but 5. So half into 5 into height. What is height? This is ED, this one. So this is 2.5. So this is 2.5 plus area of rectangle, length into breadth. Length is this AB, which is 7.5. So 7.5 multiply by this breadth, which is 5. So when you solve this, you will get some answer which should be in meter, and that will give you distance traveled by body traveling from 15 second to 20 second, and this is distance you are finding out from uniform accelerated motion. So this much for all today. Just go through slide and try to find out this distance. Already I told you these things, and if you have any doubt, please contact me. Thank you.